In this second film on industrial data communication, we will introduce the term Fieldbus. And Fieldbus is data communication designed for use within industrial sites. So it's communication between actuators, servers, computers, that is PLCs typically, and so on in an industrial plant. And it's not computers used for Google surfing or to update your Facebook status. It's simply for sending messages like the status of a temperature sensor, in this case a flow sensor, to a central computer, which may be a PLC, and back to an actuator based on that, and so on. And in order to be called a Fieldbus, you must have programmable intelligence at all nodes in a network. So this one is programmable in some way. You can go into the node here and program it to give data, for example, if it should give its data in cubic meters per second or gallons per second or what, and so on. It must be able to communicate real time, which is when you request data from this one, it must be predictable how long it takes for this one to respond. In standard communication, for example, Google searches, you don't know how long it takes for a Google search to go through. Sometimes it takes milliseconds, sometimes half a second, and sometimes maybe even a few seconds. But the thing is that it doesn't matter how long it takes, as long as it's really predictable. So each request should take the same amount of time. And you must be able to have multiple nodes in a network structure. So RS-232 is outruled because RS-232 is only point-to-point. Two-way communication, so you request data from this one and it replies back. It's not like broadcast where you only send data, even though you send it to multiple nodes. If you don't expect a reply, it's not a field bus, so it's not networking in that manner. Usually also it's an open system, which means that it's open for all vendors to use, not confined to one vendor, so it's not so-called proprietary. If you compare it to RS-232 and and 4020 milliamp current loops, it requires less cabling because you don't do point-to-point. Usually you use a bus structure in field buses, not always. But sometimes it requires less cabling. You can have sensors that do parallel information, which means that they can send both two sets of data. For example, in an earlier presentation we looked at the pressure and temperature sensor, which sends both. So it senses two things and sends it in a digital manner. In 420 milliamp current loops, you can only send data from one kind of measurement. It's easier to do maintenance. You can do calibration online, for example. You can send the data to a device on how it can calibrate. And it's expandable. It's easy to add new elements. On the downside is that it's more complex. It requires training. For the engineer, the group of engineers, it's more expensive because you have the old sensor, but now you also need the ability to communicate by networking. And there's an investment risk because there are so many different field buses around, and the chances are that one of you or more of them will be obsolete within a few years. What's the difference between an office network and an industrial network? Heat, vibration, corrosion and moisture, electrical field and magnetic fields. And here are what they do, what they introduce, what kind of problems they introduce to a network, and here's the solutions. So usually in industrial networks you have pin and socket contacts instead of touch contacts. You have high IP rating, which is water and dust proof. shielding against electromagnetic interference, and also careful grounding, and maybe even use fiber optics. In the office communication, since the 1970s, we have had Ethernet. That is the green one here. And Ethernet is still around and still used for office purposes. We have seen more wireless networks in office buildings, but in 1975, in this blue here, Modbus was introduced, and that is a serial bus, so it's not TCP/IP based. It's more based on a bus structure, and actually for RS-485 as a backbone network here. Then in 1985, a few more arrived. 1995, a great number of different field buses, and these blue here, they are all bus based, while this one is TCP/IP based. And now we have TCP/IP based networks, industrial networks that are specialized for industrial purposes. So all these green ones here are for industrial purposes, TCP/IP based. Then we still have the blue here, the bus based so-called serial, which are not based on TCP/IP. Then we start to see more wireless networks and special sensor networks, special safety networks for safe operation. So we see more specialized systems, while in office landscapes, in office computing, we simply have Ethernet and wireless Ethernet. Copper, fiber, wireless, but they are all Ethernet based. But while in the industry, we have a jungle of many, many more. So if I were to predict the future, I would guess and hope that in the future you will see fewer protocols, that many of these become obsolete, and we start to use maybe Ethernet only for industrial applications as well. Because Ethernet is so well known, even though it's not so-called real time, it's not predictable how long a message takes for a full cycle back and forth to the sensor, but it's so fast that usually the real-time problem doesn't matter. Here are a few different industrial communication protocols that will be covered in a later film. Not covered, but easily briefly presented. So, which field bus should we select? There are geographical preferences. Some are preferred in the Americas, some are preferred in Europe, some are preferred in Asia, and so on. What kind of industry do we have? The car industry prefers some standards. The power industry prefers some, and so on. What can our supplier offer? And do we need a lot of functionality or just a simple, basic, easy to set up network? So, for example, in geography, you have North American ones. They are, of course, found in Europe, but they are more popular in America. While in Central Europe, these ones are most popular ones, and in Asia you see other names. And then you have, for example, factory automation, process industry, remote management, and so on. Building automation, that one is really, really on its way up now.